Okay, so this is number 23 on lesson 2.4, page 88. Free fall. An object is dropped from the top of a 100-meter tower. Its height above the ground after t seconds is 100 minus 4.9 t squared meters. How fast is it falling 2 seconds after it's dropped? So our height function, which I'm just going to call f of x. So f of x is our height. Actually, let's call it f of t, since we're dealing with time. F of t equals 100 meters minus 4.9 t squared. T is in seconds. I'm going to sketch a graph out here. So our t-axis is the horizontal axis. That's in seconds. Our vertical axis is our f of t axis. That's in meters above the ground. All right. Let's just think about what type of graph that would be. If it's got a t squared in it and it's got a negative number in front of that, what type of graph would you expect? Parabola opening down, yep. And if you put 0 into here, what would you get?
100.
100. So it's going to start at the point 0, 100. Because you're dropping this object from 100 meters up in the air. That's a long ways. That's like about as tall as a 30 story tall building. Okay? And it's going to be an upside down parabola, so it's probably going to look something like this. It hit the ground at that time right there. The slope. If the f of t is in meters and your time is in seconds, what would be the label on your slope? Meters per second, right? So it'd be the velocity of it. So they're asking us for the velocity here. It says, how fast is it falling after 2 seconds? So somewhere must be still in the air after 2 seconds. After 2 seconds here, we need to figure out the slope at that one point. Okay? So the way we can do that is say, okay, let's just go a little bit to the right of that. Let's go a little bit to the right over here, and let's call this 2 plus h. So basically this distance between them is h. First of all, what would I call this point straight across from 2? If this is 2, what would I call this? F of 2, yep. Which I could figure out by just plugging 2 in here. And by this point, I come straight up, hit the curve, straight over. If this is 2 plus h right here, what would this be called here? F of 2 plus h. Good. So to get this slope, which we know is going to be in meters per second, we want to find this slope right here. So slope, of course, is rise over run. So what we'll do, squeeze it in right here, I think. Number 23. Actually, I need to go over here so it's on the camera. Let's go ahead and put rise over run. So for the rise, I'm going to write it like this. This is for my slope. Leave a blank spot, then you're going to put rise, I'm going to put f of 2 plus h minus f of 2 over. The run would be what? What's the run? Run is this distance. H. Yep. Or 2 plus h minus 2. Now, someone asked me in the other class, could I switch them? Could I do f of 2 minus f of 2 plus h and switch these around? Yeah, you could. As long as you switch, if you switch the top, you'd have to switch the bottom numbers also, though. Okay? The reason I'm putting it this way is it matches up better with my formula that was given here. See, this, I'm just going to use this formula that I gave you. Instead of an a or an x, I'm putting a 2 right there. So you really don't need the picture necessarily. You could just go to the slope formula and plug in 2 for a, and make sure you take your limit as h approaches 0. All right, let's keep going here. So we're still taking the limit. It's important that you show all your symbols correctly on this. F of 2 plus h, let's figure that out off to the side. So how would I figure out f of 2 plus h? Here's f of f. Here's f of t. So what do I need to do to get f of 2 plus h?
2 plus h
For t, yeah, put a 2 plus h in place of t. So I'm going to have 100 minus 4.9 times 2 plus h squared. 100 minus 4.9 times 2 plus h squared. So I need to FOIL out 2 plus h times 2 plus h. So that's going to give me 100 minus 4.9. 2 times 2 is 4. 2 times h is 2h. In the middle I get another 2h, so that's 4h. H times h is h squared. We'll multiply through by negative 4.9. So 4.9 times 4, whatever that is, I'm just going to leave it as 4.9 times 4. Plus negative 4, got to distribute the negative also, remember. So it'd be minus 4.9 times 4h. Minus again, keeps distributing that minus, 4.9h squared. So that whole thing represents f of 2 plus h. Right there. I'm going to plug this whole big answer right here, right there. Any questions about that? Here we go. I'll try to get this video out to you so you can see it. Okay, yeah. So, as I do this problem here, instead of f of 2 plus h, I'm going to write that big expression. I'm going to have to write it kind of small to fit it in here. It's going to be 100 minus 4.9 times 4 minus 4.9 times 4h minus 4.9h squared. Minus f of 2. I'm running out of room here. Let me rewrite it a little bit lower. So I don't run into that other work. So I'm just rewriting this. All right, how do I find f of 2? Right, just put 2 right here. This will be 100 times minus 4.9 times 2 squared. Which 2 squared is 4, right? Let's change that to 4. So times 4. This is all over h still. I'm still doing this formula up here. Okay. So this one here, I'm not using that right now. Okay, see anything we could cancel? Yeah, here you got minus 4.9 times 4, minus another minus 4.9 times 4. So I'm subtracted, this is being subtracted right here. So those could cancel off.
Hundreds too.
And the hundreds could be canceled off too, right? You know, 100 minus 100. So here's all you have left. We can fit right in here. This is what you have left. What could you factor out of both these terms? H. Yep. So we're almost done. That part's almost over. So we get the limit as h approaches 0. We're factoring h out of the numerator. That would leave you with negative 4.9 times 4, which I think is negative 19.6. Minus, factoring h out of 4.9h squared, that would be 4.9h. All divided by h. Just draw a line and separate these. So now what do you think I could cancel? Cancel the h's. Now I need to take the limit as h approaches 0, so I just stick a 0 right there. So I'm going to have negative 19.6 minus 4.9 times 0, which is negative 19.6. Remember, this was a slope. This is a slope formula. The y is in meters. And the x is in, t is in seconds, so it's meters per second. So we just figured out that as this object drops through the air, that after 2 seconds, it's going to be going negative 19.6 meters per second. Now, does that make sense? Some of you have had physics. How fast do objects fall through the air? What's gravity pull through the air? Right, if I drop that, after 1 second, it's going, right, negative 9.8 meters per second, negative, it's going down. After 2 seconds, it'd be going negative 9.8 times 2, negative 19.6 meters per second. So that is the right answer. We're ignoring wind resistance. And the other short way to do this would be to take the derivative. So the derivative of this, derivative of 100 is 0. You might remember this from pre-calc 2. The derivative of this, we take 2 times negative 4.9, would be negative 9.8. Take that down to the t to the first. Then simply plug in 2 seconds. F prime of 2, negative 9.8 times 2 is negative 19.6. Okay? So, obviously this is shorter. Because, you know, Litter says multiply these numbers, plug that number in, you get the answer. Yeah, I know you could do that, and that would be easier, but the emphasis here is understanding what's going on, understanding the calculus and how it's being used, and even on a calculator. Let's show you on a calculator quick.
Do we have to do that when I'm test?
Yes, the next 2 tests you're going to have to do it the long way, at least 2 or 3 times in each test. Okay? After that, we'll switch to doing it the shortcut all the time. So you're going to need to be able to show this work. All right? All right, let's, on your calculator real quick, type in that original equation, 100 minus 4.9 t squared. I've got it right there. 100 minus 4.9 x squared. You can set your window. I did this first hour, so that's why I still have it on there. X min of 0, X max of 4. So I'm going to graph it for the first 4 seconds that it's falling through the air. Remember, this thing is dropping from, what does it say, 100 meters. That's the length of a football field, but up in the air. That's over 300 feet tall, so it's dropping a long ways. So I'm going to graph its the fall of its height over a time period for 4 seconds. Got my y min at -5, my y max at 105. Hit graph. I want to get the slope at 2 seconds. I push second trace. Which one's going to give me the slope?
6.
Number 6. dy over dx. That's another symbol for derivative. And then hit 2, enter. And again, we can see there's the velocity, negative 19.6 meters per second.